resolution and LED headlamps. Do we have other high resolution too? Yeah. Oh. Very good.
Good afternoon. So Sunex is a tier 2 supplier for the automotive industry for over 20 years. Our team in the United States, together with our team here in China, we have factories in Shanghai, Kunshan, and Nantong. We have delivered millions of lenses for automotive cameras. And this is the know-how that we're now taking into the lighting market. In the last 5 to 6 years, we have built many proof of concepts, samples, mini-series, and we now have several products actually in mass production. And you could say that in Europe and North America, we actually work with every major tier 1. And this is something we want to now extend to Asia as well. So today I want to talk about hybrid lenses, and in particular for hybrid lenses for systems that use the micro LEDs. To create a baseline, I'm looking first at the matrix LEDs, right? And if you look at the matrix LEDs here on your left side, we typically see 1 to 3 elements. We use obviously glass and plastic. And if you look at the individual elements, they can be quite complex. And the main reason is that sometimes they maybe combine a collimator and a projection optics in a free form. And they quite often have advanced features on the flange to do a direct mounting into the headlamp or into the headlamp module. Now, if you compare this with micro LEDs, we typically see a little bit more elements, maybe 3 to 4. We have done systems that use 6. We also have done systems that only use 3 lenses, but typically there's a little bit more optical complexity. Same materials, we all use glass and plastic in the different forms, but a key difference here is because of the precision that is required. Those elements don't get directly mounted into the module. They all get pre-mounted and pre-aligned to each other with very precise air gaps into a dedicated barrel. So our customers are not receiving individual components, they receive a completely aligned and tested projection module. That's a key difference. So the question is, why are the optics for micro LEDs so much more complex? And in a nutshell is because the micro LED has very, very small pixels and a very high pixel density. So if you put 16,000 or 26,000 pixels into less than half a square centimeters, the requirements for the optics is increasing dramatically. And here today I want to talk about 3 things. So one is the pixel size. I already mentioned it. The pixels are very small. It's not unusual that we see that the pixels are 10 to 20 times smaller than that maybe of a standard matrix LED. What that requires, if you have small pixel, obviously your customer is expecting to see that pixel quality on the street. So what you actually need now in projection optics is the precision and know-how of imaging optics. And this is one of the main reasons why Sunex actually moved also into this lighting industry, because our imaging know-how over the last 20 years, and that includes design as well as manufacturing processes, is now very much applicable to the lighting sector. One big one is thermal load, especially like the title of my talk is the hybrid designs, right? Hybrid, we're combining glass and plastic. And the moment you use plastic, the thermal load becomes really, really difficult to manage. Micro LEDs get very hot, especially compared to matrix LEDs. Picking the right material, picking where these materials have to be in the optical stack, all those things make it very challenging to use plastic. And I'll get to this in a second, a little bit more detail. The third one is the form factor. This is largely driven by the OEM, right? Everybody wants to have it smaller, wants to have it slimmer, and that simply brings design constraints with it that our designers have to account for. What those 3 things combine together is in the end that you have an optical system where every single component and the entire system have to be extremely tightly controlled when it comes to the tolerances. And again, this is something maybe new for some people that are since decades in the lighting market. If you come from the camera side, from imaging optics, this is nothing new. So we can really apply what we have learned here in the lighting sector very well. So I mentioned it before, I want to talk a little bit more about thermal because this is a really big challenge when it comes to plastic. And there's 2 different things. Over here, and don't nail me down on the exact numbers, but it's a sketch. So here on this side, you have the micro LED, a very, very hot light source. So the first challenge that you have that is within the optical stack, you have a temporal gradient. That depends on what glass elements you maybe have there. And this is something where if you use plastic, you have a repeated and constant exposure to high temperatures on the plastic element. And this is leading to something which we call aging, right? What it makes actually, or what it implies is that the optical performance of that particular material is changing over time. And as you know, automotive is requiring very consistent performance and reliability over 15 years. So understanding this impact is key. So let's assume you have managed this one, right? You would avoid putting a plastic element right here, so you can run simulations and measurements to understand where's the safe distance to, for instance, use PC or PMMA materials. Now, the second challenge is that you have a dynamic temperature range, right? And that's the operating temperature. The vehicle can be parked and be used maybe negative 40 Celsius all the way up to 105 Celsius. So the plastic element that's here in the front gets exposed to that as well. And you know plastic is expanding and contracting with temperature. And all of that is again impacting the performance. So having an inherent understanding and experience how to deal with those different factors is important when creating a good lens. Here, what you see there at the bottom, on the camera side, it's very normal for us to use plastic, multiple plastic elements in an optical stack. But it's different type of plastics. They are high-end automotive grade plastics that kind of navigate some of those challenges, but we can't really use them yet in lighting optics because of the size of the optics. Those materials become too expensive, and then you can actually stick with glass. Because one of the goals for hybrid systems is also to reduce the cost. So making a good high-performing hybrid lens is a little bit like cooking a good noodle soup, right? Everybody has the same ingredients. We have the same spices, we have the same herbs, the same vegetables, the same meats. But which ones you pick and how you combine them and how you cook them is defining if you create the perfect soup. And that's the same thing with a lens hybrid design. We all use the same materials. We have glass and plastic, and everything has their advantages and disadvantages. For instance, if you start from the optical performance, there's a lot of different glass types you can choose from. It's like a huge spice rack you can pick from. Plastics, they are less. I just mentioned typically we use PMMA and polycarbonates. But one big advantage of plastic is, since you injection mold it anyway, an aspherical surface which can improve the performance basically comes for free. So it's really like cooking and understanding how to combine those different things. If you go over all the way to this side, reliability, glass doesn't really have an issue with lifetime. It's very thermally stable, we use it for decades, no one has a problem. A little bit bigger challenge for plastic. On the other hand, everybody sees outside, you see the nice rectangular lenses. For glass, that's typically an extra process that costs money by truncating a circular glass element to a rectangular shape. Again, those things are coming for free when it's about plastic. So again, it's really about trying to understand how to combine it. If you know how to do it, then hybrid lenses can be an ideal solution for optimizing for size, performance, and cost at the same time. What you see here, I'm not sure who has an optics degree here, but what you see is an MTF graph. It basically shows resolution and contrast over the field. You want to have those lines being very high and very consistent over the entire field. That means you just have a good image or a good projection on the street. The one on the left is what we call the nominal design. That's at 25 Celsius. Now, if you know how to use plastics and if you know how to deal with the temperature changes I just mentioned earlier, then you can actually design something that here on the right side with 90 degrees Celsius has the same, if not even the better performance. And that's the goal. So every time we do something, you want to have a well-balanced design. A design that is not sensitive to temperature, a design that is very highly manufacturable and meets all the customer requirements. So just a quick shout out to hybrid. I mentioned it before, we do automotive camera lenses since 20 years. In the beginning, those lenses were all glass. Today, there's a lot of plastic in there. We have maybe shipped 110, 120 million of those lenses for cameras, and they're all in the street, and it's very well understood. And we do believe this is also the technology for next generation lighting. In lighting, in general, what we see, there's the ask to make things smaller. There's the ask to reduce cost, which goes along with reducing elements, but still maintaining good and high performance. And what you see here at the bottom is a result of that. We already have designs where we reduce the size dramatically. If you become too small, which what we can do, you have to move over to glass because, as I showed before, you simply can't put plastic in front of the micro-LED. So if you want to see some of those things, also the lens I just showed before in the MTF graph, you can actually come down to our booth. We have a live demonstration there. You see that, and also some of the graphics I showed. If you want to pick up one of those brochures, the graphics are actually in there, and then you can also download them from the web. And with that, exactly 10 minutes. Thank you. Wie wir in Deutsch sagen, das war eine Punktlandung.
Yes, this was a noodle soup Punktlandung. Very nice. So I will never, ever when I think about Sunex, it's noodle soup. It's good. It's good. We come to the next presentation.